All right, when we see something like this, like the integral of 1 over a quadratic, we're thinking inverse trig stuff. And now it doesn't look like that, but this is how you approach a problem like this. I'm just going to pull this guy aside. And what I'm going to try to do is I'm going to try to make this look like 1 over x squared plus 1. I'm going to try to make it look like that, where it's not x. Maybe I should have used u. But I want to make it look something like that. So what I'm going to do is I'm going to pull x squared plus 4x and over here plus 5 to the side, and I'm going to complete the square. Now completing the square has you take half the number in front of x, which is 2, square that, which is 4, and then add that over here. Now if I'm on the same line over here, if I do something like that, if I add 4 to this expression, I have to subtract 4 to the same expression to balance things out. But when I do that, that allows me to turn this into x plus 2 squared, and this magically turns into plus 1. So now I can rewrite this integral as 1 over something squared plus 1 dx. And I could do u substitution and make it look like the inverse tangent stuff. So I'm going to let u equal x plus 2, which means du dx is going to equal 1, and du is going to equal dx. So now when I fill all this stuff in, when I put this all together, right, I'll have the integral of 1 over u squared plus 1 du. Okay? That becomes the inverse tangent of u, plus that arbitrary c, of course. And once I plug the fact that u is x plus 2 back into u, I have the inverse tangent of x plus 2 plus c. And that's going to be my guy. Okay, tricky stuff, very tricky stuff. Evaluate the integral of 1 over the square root of a quadratic. When I have the integral of 1 over the square root of a quadratic, I want to try to make it look like this. I want to make it look like the square root of a quadratic and see if I can pull this off. If I can do that, right, I can think inverse sine thoughts because the inverse sine comes from this. So this is what I need to do. Okay, let's get rid of that. I'm going to pull out just the stuff underneath the square root. Okay, so negative x squared minus 2x plus 8. Okay, and I'm going to think completing the square thoughts. Okay, so let's do this. Let's pull out a negative. So that leaves me with x squared plus 2x. Let's leave some space right here and keep that plus 8 out off to the side. Okay, now completing the square, this is going to be tricky, so kind of follow me here. I'm only inside the parentheses right now. If I were to take half of this, which is 1, square it, which is 1, and add 1 to that, I'm good. Now me adding 1 to this is the same as minus 1 in this whole chunk right here. If I were to subtract 1 from an expression, the only way to balance it out is if I add 1 over here. But this is good news, because what this gives me is negative. That becomes x plus 1 squared plus 9. Now rearranging it like that, right, because it's the same thing, and then turning u into 3, I now have what I showed you I needed from before. Okay, so I'm going to rewrite this guy up here as that, so I now have the integral of 1 over the square root of 3 squared minus x plus 1 squared dx. Using u substitution, I will let u equal x plus 1, so du dx is going to equal 1, and du is going to equal dx. So now I have the integral of 1 over 3 squared minus u squared du. Okay, that becomes the inverse sine of u over 3 plus that arbitrary c. Replacing u, I now end up with the inverse sine of, what was it, x plus 1 over 3 plus c. So definitely not an easy problem. Definitely not an easy problem. I got a little stumbled up here when I was trying to remember what I was supposed to do because inverse trig functions are not my favorite. But we end up with this, so yeah, not fun. Evaluate x squared, the integral of x squared over x squared plus 16. Now usually when we see something that's all like quotient rule-y, we try to think u substitution. Well, that's not going to happen here. If you have the same degree up here that you have down here, you're going to approach this a little differently. I'm going to use polynomial long division. What I'm doing is I'm dividing x squared plus, 0x plus 16 divided by x squared plus 0x plus 0. X squared goes into x squared once. And so we write this down, x squared plus 0x plus 16. We subtract the entire row like that. You go away. Fortunately, you also go away, but you're left with negative 16. What does that mean? Well, this means we have 1 minus 16 over x squared plus 16. So now I can rewrite this problem like this. The integral of 1 minus 16 over x squared plus 16 dx. Split them up. The integral of 1 dx, I think I can handle that, minus, and let's rip out, I don't want to rip out the 16. I'm going to leave it there and you'll see why. The integral of 16 over x squared plus 16 dx. Now this guy is as friendly as they get, okay, x. All right, I'm not going to lose sleep over that. This reminds me of this. The integral of 4 squared over x squared plus 4 squared dx, which is giving me inverse tangent thoughts because that's exactly what it is. All right, x is still there, minus 4 times the inverse tangent of x over 4. Now I can't forget that since this was indefinite, that arbitrary c that's just kind of lingering. But that's what you get with a problem like this, okay? Inverse trig functions are tricky. This one forced us to do a little bit of polynomial long division, but we did it and we had fun.